All right, here we go. Let's take a look at the chain rule. This is a great section here. We're going to use a lot. Finding derivatives for the rest of the year. Chain rule, I like to say that it's off the chain. I don't know if people still say that, but I still say that. It's so good, it's off the chain. And why is that? Well, let's take a look at this. Remember, 3x plus 1 squared is really just this. So I can multiply this out. And don't write this down. I'm going to show you the chain rule here in a second. But just to make sure the chain rule does indeed work. And then I could say, oh yeah, multiply this out. I'll get 9x squared plus 6x in the middle plus that 1. And then now I could derivatate, not a word, I could take the derivative 18x plus 6. So that's pretty cool right there. And in fact, I'm going to save that. That is the derivative. There is the answer. Spoiler alert, there is the answer. Can I do it with the chain rule so we see what the chain rule is all about? Here's how the chain rule works, and this is awesome. This is what you should write down. Basically, I have a function in a function. I have like this one function here, 3x plus 1, and then I have another function, a squaring function. So maybe you could think of it as u is like 3x plus 1. And what am I looking at? I'm really looking at u squared. So when I do this, I'm going to take the derivative of this. All you do is the power rule. So I'm going to go ahead and bring the 2 in front. So it's 2 times the coefficient here, which is 1. 3, you freeze this. This stays exactly the same, and you drop that power down to 1. Then whatever this was in here, this inside function, you take the derivative of that. So the derivative of 3x plus 1 is just 3. So what do I get here? Well, I get 2 times 3 is 6. 3x plus 1 to the first power is just that. If I distribute that 6, what am I going to get here? I get 18x plus 6. Does that look familiar? Yes, there it is. It's over there. So I could have multiplied it out and done it, or I could have done the chain rule. So this is pretty awesome, especially for people who don't like to multiply a lot out. So how's the chain rule work? If you have a function and a function, right now I've got the g of x inside the f of x, and we could have wrote that over here too. I know I could have said the f of x is x squared. In this problem, the g of x would have been 3x plus 1. So the f of g of x is what? It's going to be 3x plus 1. Put that in there and square it. So you're putting this into this. So that's what this notation means, so don't freak out by this. So the notation means, what do? Well, you take the derivative of the outside, so you take the derivative of the f of g of x. And then what do? You take the times it by the derivative of the g of x. So that is the chain rule there, which is pretty cool. Yeah, let's move on. Let's do some problems with it. So it's kind of weird to look at the formal definition. We'll do more of that later on. Let's just get good at the chain rule. So I'm going to do the chain rule, and this is very, very similar here. So let's just practice doing it. So I don't want to multiply this out, x squared minus 5 to the 4th. Can you imagine? That's going to take me 10 minutes. I'm not going to do that. So what am I going to do? Chain rule. Bring the 4 in front like our little power rule. You freeze whatever's in the grouping symbol. In this case, x squared minus 5. You drop that power 1. Now, what is the derivative of anything in this grouping symbol? That's going to be 2x. And so what is my derivative? My derivative will be 4 times 2x is 8x. And then I'm going to leave this bad boy alone. Isn't that cool? That is way better than multiplying out. Way, way, way better. So this is great. How about this? Is this a chain rule? Sure, this is a chain rule. Think of this grouping symbol really as, just rewrite it, 4x minus 3 to the 1/2. And now I'm going to take the derivative of that after I rewrite it. Follows the same rules. The 1/2 comes in front. You freeze whatever inside the grouping symbol, still stays the same, and then you're going to drop this a power, so it turns into negative 1/2. 1/2 minus 1 is negative 1/2. Don't forget to go ahead and multiply what's in here. We got 4, the derivative of the inside grouping symbol. And then great, now what are we going to do? We're going to rewrite this bad boy. So remember, negative exponent moves it to the bottom. If you want, you can cancel this. 1/2 of 4 is just 2. So what's going to be on top here? The 2 stays on top. The square root goes to the bottom. We got 4x minus 3, and that is my derivative. So I did that pretty quick. So the 1/2, the 2 here stays on top. The negative moves to the bottom, and then I went ahead and made that back to the square root. Pretty cool. All right, check this one out. So we got 2 more to try here, and I put a Crunchwrap Supreme on there. I like to think this is Crunchwrap Supremes. You've got a function and a function. It's like a taco and a taco. You got a hard shell taco and a soft shell taco. So if you just think of that, I think you'll be good to go. Maybe not. Maybe that's a stretch. I just really like Crunchwrap Supremes is why I put that on there. All right, so can I take the derivative of this? Sure. Does it matter if I put a number out front? No, not at all. 3 times 2 is 6. You freeze the inside of the grouping symbol, drop that power down, and then go ahead and take the derivative of the inside of the grouping symbol. This is going to be plain old 4. Let's clean this up. So we got y prime, 6 times 4 is 24, and I'm good to go right here. Done and done. So chain rule is pretty awesome. One more of these, and we're going to up the ante here a little bit. What if it's in the bottom of the fraction? Sure, no problem. I just need to rewrite it. So this is really 5x minus 3. It's a third root, so I'm going to take the 1/3, and it was in the bottom, so I'm going to make it negative. So don't freak out. We can rewrite these things, no problem. Once you rewrite it, follow the rules, it'll be negative 1/3. Rewrite this as 5x minus 3. This is kind of weird. Negative 1/3 minus another one will get you to negative 4/3. So that's kind of weird. Don't forget, whatever I freeze this, so I got to take the derivative of the inside here. In this case, it's just going to be plain old 5. If you want, I'll take my time simplifying this one. So we got 1/3 5, that's negative 5/3 if you want to do that. Then what happens to this? This is the 5x minus 3 to the negative 4/3. So in this case, what am I going to do? The negative moves it to the bottom. So on top, I'll be left with that negative 5. On bottom, I've got that 3 from here. Now this moves to the bottom, so this is the third root of what? Of that whole thing, 5x minus 3 to the 4th power. That's what the 4/3 means. So you're rewriting that. This is my derivative, my f prime. Boom, right there. So I do want you to rewrite these things when you're done. Don't leave the negative exponent. Go ahead and simplify that out to that right there. Dude, we're cruising. All right, here we go. So let's take a look at this bad boy here. We're going to try to find the derivative, evaluate at negative 3. So what does that mean? I look at this function. Oh, this one's interesting. Check it out. I actually have what going on here? I have a u times a v. This is a product rule going on here. I've got two functions. My u, and if you want to write down, you can, is 2x. My v is what? The square root of 1 minus x. So this is definitely a product rule. In the product rule, it looks like I'm going to have some chain rules. So I got all kinds of good stuff going on here. So remember, product rule is u prime v plus u v prime. So let's plug those bad boys in here. What is u prime over here? It's just 2. What is v prime? Well, you may want to rewrite v as 1 minus this to the 1/2. So v prime will be, do a little chain rule here. I can bring the 1/2 in front, freeze the inside of the grouping symbol. 1/2 minus 1 is negative 1/2. And then don't forget to take the derivative inside the grouping symbol. So I froze it. What's the derivative of 1 minus x? Well, it's just this minus x gives you a minus 1 when I take derivative. And we should probably clean this up a little bit. If I clean this up, I'm looking for what? So this negative 1 will stay on top. The 2 is on bottom, and then this negative moves the square root to the bottom. So it should be 1 minus x like that. Awesome. Now let's plug that in. We're going to come over here and plug it into our thing, to our product rule. So u prime is 2, so I'm going to have 2 times v. v is the square root of 1 minus x. I'm going to add u, which was plain old 2x. We'll put him in parentheses. And v prime was that monster right there, this bad boy like this. So it kind of gets a little crazy here, but don't freak out. You could clean this up if you want, like your 2's cancel. I don't know what else we can do besides that. But it doesn't matter. What I recommend is if I'm evaluating at a point, don't simplify. There's no need to waste your time simplifying. You may make a little mistake. Just plug it in. Plug in negative 3. So wherever there's an x, plug in that negative 3. So it'll be 2 times 1 minus a negative 3. Then we'll have 2 times negative 3 here when I replace this x with negative 3. And then I've got this big parentheses with 2 all over 1 minus negative 3. So plug it in there. This works out well, doesn't it? This is really 2 times the square root of 4. This is going to be 2 times 3. That's like minus 6. And we are going to times that by negative 1 all over 2 radical 4. Awesome. So 2 times the square root of 4, that's just 4, isn't it? And now if I want to do some, I'll do a little bit. Those will cancel and give you a 3. So I got negative, negative. This looks like plus 3 on top all over 2. 4 plus 3 halves. And if I want to make this, let's just finish it out. 8 halves plus 3 halves, 11 halves. Boom. There it is right there. Awesome. That was pretty cool. So a little product rule. We could do quotient rule. But chain rule is just in there. It's just one of our derivative tricks now. Awesome. This is the last one. I thought I'd throw something nasty at you. We're not going to go crazy simplifying this, but don't freak out. Just follow your rules. Check it out. I've definitely got a u over a v, and then I've cubed it. So what do I have? I've got a monster here. I've really created a monster, but that's okay. You can just follow your chain rules. This is my function on the inside being cubed, so I can do the chain rule. It's just 3. Rewrite everything in here. This is just freeze it. Whatever's in the grouping symbol stays the same. Drop that power to 2. Well, now I need the derivative of that hot mess. So what's the derivative of that hot mess? Well, you're going to have to do a little bit of u prime v minus uv prime all over v squared. So it could get a little crazy here. I'm going to write this out a little bit. If u is the top function, it's t squared plus 1, which means u prime will be what? 2t? And v is the bottom function, 2t minus 5. V prime will just be 2. So that's not too bad. Then when I plug it in here, so we got u prime is 2t. Times that by v, we got t minus 5. We're going to subtract u, which was t squared plus 1. And what is v prime? V prime is just a plain old 2. All of this goes over v squared, which was what? 2t minus 5. There it is right there. Holy cow. That is just the derivative of the inside right there. So what I'm going to do is, I don't want to rewrite that. I'm going to copy and paste it. Bring that bad boy down here. I can't have that equal sign in here, though. Let me get rid of that. So that guy's gone. All right, so there it is. This, let's just put it in parentheses, is the derivative of the inside. I'm not going to clean it up at all. This would be the derivative. Yeah, this is going to happen a lot. No, not really. That's pretty crazy. But it could. Like, you could do this. Just follow your rules, and you're good to go. If you want to clean it up, we could distribute up top here a little bit, and maybe it's not that bad. But for now, I'm just going to leave it because that's kind of a hot mess. As long as you get the idea, we've got chain rule. Inside, we had a quotient rule. All right, here goes. So the last problem here. So now we're going to mess around with the notation here a little bit. So what is my ultimate goal here? I want to find the derivative of f at 4. So let's evaluate this at 4. So I got some weird things going on. If the f of x equals the g of x squared, so this is chain rule. I've got a function, the g of x, inside another function, the squared function here. So if I want to find the derivative, what am I going to do? I'm going to just say it's 2 times that. You freeze the inside, drop that power down to 1. You don't have to write it. And then don't forget to do the derivative of the inside, so it'll be g prime x. Very nice. Now I want to evaluate this when it is 4. So you're going to plug in 4 for this. So it'll be 2 times the g of 4 times the g prime of 4. So now it's just a matter of a little plug and chug here. Let's plug some numbers in. This will be 2 times, what's the g of 4? G of 4 is 4. That's nice. So we got 2 times 4. G prime of 4 is negative 2. So I'm going to say 2 times 4 is 8 times negative 2 is negative 16. Awesome. Very, very nice. Will this freak you out? So I'm really just trying to throw you some notation here. I want to find the derivative of this. Before I find the derivative, though, let's go ahead and just rewrite it. Remember, square roots, I'm just taking the h of x, and I'm raising to the 1/2 power. So rewrite it. Now we can take the derivative. So I'm going to say what? That 1/2 comes in front. You freeze the inside. Drop that power. So 1/2 minus 1 is that negative 1/2. Don't forget to take the derivative of the inside, which would be h prime of x. Holy cow. Can we go ahead and plug in 4? Sure. And maybe I want to rewrite this a little bit. Basically, the negative exponent moves that to the bottom. So we got the 2 on the bottom. We got the square root of the h of 4 on bottom. And then this h prime is on top. So it looks something like this. And now let's evaluate. So if I go ahead and put those numbers in, we're going to say what? The h prime of 4 is 5 all over 2 times the square root of the h of 4, which is 9. That should be 2 times 3 on bottom. So that should be 5/6. 5 over 6. Super cool. All right, one more of these and we are done. Let's wrap this up. This is the definition of chain rule right here. This is classic. So we got the f prime is going to equal, we've got the g of x is inside of the h of x. So we've got a function and a function. So what do? I take the derivative of the outside function. This will be h prime. Inside, you leave it alone. Then what do? You take the derivative of the inside, so this will be g prime x. So if that makes sense to you, you're golden. That is the chain rule right there. So this is kind of weird. When I go to plug in 4 here, what am I doing? I'm saying the h prime of the g of 4 times that all by the g prime of 4. So if I sub in some numbers here, luckily, I hope this works out. The g of 4 is what? G of 4 is 4. That definitely hooked us up. G prime of 4 is negative 2. So I'm not done. I'm taking the h prime of 4. That's a terrible looking h. That is getting worse. That is an h, though. No, if I'm just making it worse. Is it get a little bit better? Okay. So the h prime of 4. Well, luckily I know h prime of 4 is 5, so it had to work out perfectly. This is 5 times -2. This bad boy is -10. Very nice. That is the chain rule. Again, it is off the chain. What? Good luck on the mesh check. Peace out.